Hello, this is Nikki Jackson, one of the adjunct instructors for Concord Career College, going over some examples from Module 3, Math 1320, College Algebra, some homework problems. So please be patient. I'm going to do several back and forths with going over the actual problems themselves. So if you can see my hand waving, that's because you're actually going to see the recording. So if there's a lot of zooming in and out, that's probably because we're going to try to make this as visible as possible. So bear with me. So let me zoom in on this one. This is one of the first examples for the homework for Module 3. So hopefully you can see that very carefully. You have an equation given to you, and rather than trying to solve for the equation right here, what it wants you to do is test all three of these answer choices to see which one is actually true. So I'm going to flip the page, and you're going to see a bunch of handwriting. Hopefully you can actually see my handwriting in the different colors. So it's a multiple choice problem. And here's once again the actual equation. When it's your turn to do this, you're going to eliminate the options and test the choices. Now what I mean by test the choices, you're going to actually plug and shove. So for the first option, you have the point -1 and -11. The -11 is the y portion, the -1 is the x portion. So notice how I substituted in. So -1 times 7 gives you -7, -7 minus 4. Since they equal one another, we can use this as an option. So yay, we can use this one. This is an actual answer choice. Yes, it's going to be true, and yes. Option 2 gives you the point of 2 and 10. Once again, we're going to substitute y as our 10, and then 2 as our x. So 7 times 2 is 14. 14 minus 1 is 10. Notice how this one is also true. Both numbers equal one another, so this is also an option. So right now we got option 1 and option 2 is true. Your next one is option 3. So let me push it up just a little bit so you can still see the equation. For option 3, you have the point 0 and 3. So once again, 3 is going to be your y value, so I substitute that in. And x is 0, so I substitute that in. So 7 times 0 is 0. 0 minus 4 is -4. Well, notice right here, 3 does not equal -4, so that is a false, meaning that you can't use this as an option choice. Now I went through that kind of fast, so make sure that you pause and rewind this option for this particular example if you have any more questions. Your next one is dealing with graphing. So once again, let me zoom in so everybody can see it. Take a moment to review it. So what you see is the equation in standard form of 5x minus 3y equals -9. You then have to fill in the blank and then graph it. So I rewrote it for you. So hopefully you can see the blue. Let me zoom out so you can see everything that I did for this one. So giving you the actual equation, the equation itself is 5x minus 3y equals -9. On the table, what's given to you on the computer screen, you had x and the x values. So you had -3, 0, 2, and 3 as your x values. You had to fill in the blank for your y value. So this is what I did. Given that you had x is -3, I substituted x as -3, so now I got 5 times -3 is -15. Bring down your 3y, bring down your -9. These are coming from the actual equation itself. We want to solve for y. By doing that, we combine like terms by adding 15 to both sides. Then we divide everything by -2. Hence, y is -2. I said -2 earlier, but we got -2 in the answer. So we fill in the blank right here. The next one, we're going to substitute x as 0. So 5 times 0 is 0. Bring down your -3y. Bring down your -9. Divide both sides by -3. Hence, your y now is +3. Remember, two negatives give you a positive. So I'm going to scooch just on up just a little bit so you can still see the problem. So your next one, and I'm going to cover this up just a little bit. We're going to substitute x as 2. Plug it in. Once we solve for y, we have 19 over 3. Yes, that's why you have it right here. Then your next one, you have x is 3. Substitute it in, now we have y is 8. So again, feel free to actually pause the video and see what I did. Now we're going to graph it. So we have these points now. So using this table, here are your points. So I'm moving it up so you can actually see it very well. So we're going to plot those. Now you are going to be using the computer, so yours is going to be a little bit different. And I'm going to move my points out of the way in just a moment so I can zoom in on the graph. Make sure when it's your turn to do it, pay close attention to your tools on the right hand side of how you're going to graph it. So I'm going to zoom in. So one of your points you had was -3 and -2. So what I did right here, and let me try to turn it around. There we go. So up here you should be able to see it. You got -3, -2. So I started at 3, go down -2, made my first point. The next point is 0 and 3. So start at 0, go up 3. Notice how you're looking at your numbers. So if it's negative on the x-axis, you're going to start on the left. And if it's negative on the y-axis, you're going to go down. If it's positive for your x coordinates, you're going to go to the right. And if it's positive for your y coordinates, you're going to go up. So back to your 0 and 3. So you got 0, go up 3. Then we have 2 and 19 over 3. Do a quick estimate of 19 over 3. We know 3 can go into 19 like 6 times. So here we go. Here we go. 2. We're going to go up 6 times and just a little bit over 6. That's your next dot. And then your last one is 3 and 8. So 3 on the x-axis. You go up 8. You're going to connect your dots now. Notice how it's extending out because you want it to be an actual line. And it's asking you to graph the equation. So what I'm going to do now is actually show you what your line is going to be to make it a little bit easier. So you actually have 5x minus 3 equals -9. So if I was to simplify this and put it in slope-intercept form, and I have 3y equals -5x minus 9. Divide everything by -3. So now I have y equals positive 5 over 3x. -9 divided by -3 gives you a positive 3. So this is actually your linear equation now. So in case you've forgotten, this one's right here was in standard form. We put it in slope-intercept form. But there are more like this. So let me give you another example. Let me zoom in. I'm not zooming in too much. There we go. So notice how you have this problem. It's given to you in slope-intercept form. So take a moment to actually look at it. So I'm letting you look, and now I'm going to write it out. So I want from standard form to slope-intercept form. So I'm going to take away my x from both sides. Let me zoom out so you can see my writing. Now I have 2y equals -x plus 6. Because notice how one is a number, one is a variable. Divide everything by 2. So now I have y equals negative 1 over 2x. Now where am I getting that from? You see 1x and it's negative, and then that's over 2. Bring down your plus sign. Now you have 6 divided by 2, which gives you 3. Alright, here we go now. For graphing, let me zoom out. Notice how you already have a line. So when we're going to graph now, notice how it says y equal. So on the y-axis, we're going to look for positive 3. So I'm putting my first point at positive 3. Now here we go with our slope. Our slope is like our GPS. So I see a negative 1, so I'm going to go down 1 unit from that 3 and go right 2 units. So look at this. From that 3, I'm going to go down 1 because it's a negative 1. And always go right. Then I connect my dots with a full line. You have now officially graphed that. So what we did, we converted it from standard form to slope-intercept form. Here we go with another one. So check it out. So once again, let me zoom in so you can actually see what I'm doing. So here goes your equation. The equation itself is in slope-intercept form, and I know that because slope-intercept form is considered y equals mx plus b. Now later on in our lesson, I'm going to go over that with you. So in fact, let me jot that down real quick, and not just repeat myself. So slope-intercept form, which is one of the easiest ways to graph, it's going to be y equals mx plus b. Then we have standard form, which is ax plus by equals c. Now, though your variables are different, notice how you still got an x and y, which represent your axis. So jot that down real quick. So let's go back to the actual problem. We have in slope-intercept form, y equals 1/2 x plus 1/5. What it's asking you to do is to graph it. So to graph, we're going to start at 1/5. Now 1/5, we know that that's a fraction, so it's going to kind of look like it's almost a decimal. Unfortunately, we don't have decimals right here, but when you do it in your turn, you will be able to actually enter the points. So one of the first points that you're actually going to plot is going to be 0 and 1/5. This is considered your y-intercept. And how did I do that? I just let x equal 0. So when I let x equal 0, I have y equals 1/2 times 0 plus 1/5. So voila, y equals 1/5. So that's where I got that point from. Go up here to your graph. We're going to go to 0 and go up 1/5. So it's the itty bitty mark. So there you go right there. That's my first stop. Now we're going to find our x-intercept. So to find the x-intercept, we're going to let y equal 0. So 0 is y, 1/2 x plus 1/5. So subtract 1/5 from both sides. So now I have negative 1/5 equals 1/2 x. I'm running out of room for that one. So let me find my other sheet of paper that had that written on it already. Which at great convenience, I can't find when I need it. Well, shut it at quack quack. But that's cool though. So now we're going to do the reciprocal. So that's 2 over 1 times negative 1 over 5. 2 over 1 times 1 over 2 x. Let me zoom in. These are going to cross out. So now I'm left with x. Multiply. So we got negative 2 over 5. So now my x-intercept is going to be negative 2 over 5, 0. So that's my x-intercept. Now what intercepts mean are where they cross the x and y axis. So now we got our two intercepts. We already plotted our y-intercept. Let's plot our x-intercept now. So let me zoom out so you can see it. So our x-intercept is -2/5. Well, we know it's not quite -1. So that's going to be between 0 and -1. So I'm going to put my next dot right there. Connects the dots with your full lines. When it's your turn to do it, make sure that you actually put them as ordered pair. But we still got a lot of graphing to do. Our next one should be rather more simple. I'm just going to say that. You have an equation where y equals 3. So you're going to find 3 on the y-axis. So boom, bam, pow. Here's +3 on the y-axis. Draw a horizontal line through that 3. Now the reason why it's horizontal, not up and down, but notice how no matter where you go, it's still at 3. Plus, if we did a vertical line, it would just be on the y-axis. So you're done with this problem. So when you're looking at the y-axis, draw a horizontal line. So again, the first step, plot a point at +3 on the y-axis, then draw a horizontal line. Now, if you're doing horizontal lines, you may be wondering, when do you do vertical lines? At least to our next example. Given to you, you have the equation x equals -6. So let's find -6 on the x-axis. So here it goes right here. I'm going to plot it. Then I'm going to draw a vertical line going straight through the -6. The reason why it's vertical, because no matter where you go up and down, it's still at -6 on the x-axis. However, if you drew it vertical, it wouldn't be going through anything. It would just be on the x-axis. So be mindful that when it's just y equals, you're going to have a 0 slope. When it's just x equals like this one, it's going to have an undefined slope. But wait, there's more. Alright, ladies, gents, and individuals, check this one out. Now you have the graph given to you, but what you don't know is why in the world do I have some shading and some dashed lines and what in the world is going on. Alright, so you may notice that you have your inequalities. When we're doing Module 2, your inequalities were dealing with the number line. With this time, we're not going to do that. So let me get you started first. So here's your inequality. So one of the first things that we're going to do is rewrite it where y is completely isolated. Now the reason why we wanted to do this is because it makes the graph a little bit easier. So notice how I subtracted x from both sides. Bring down -y. And you got -y greater than -x plus 1. Well, we can't have this right here. Remember when we had to flip our sign? And the reason why we had to flip it because x can't be negative. So the reason why I flipped it, just divide everything by -1. So that's what I did right here. Once I did that, it flipped. So now I have y is less than x minus 1. Now for Module 2, you may remember that your less than will require shading. For a graph, it will shade under and dash over. So let's go into more details about that. So this is an ideal time for you either to pause your video and jot this down real quick. So when it's less than or equal to, when you're dealing with an inequality in graphing, it's going to be a dashed line and you're going to shade under the line. When you're dealing with an inequality that is less than or equal to, it's going to be a solid line when you connect your dots and you still shade under. With greater than, it's going to be a dashed line when you connect the dots. But when it's time to graph and shade over the line. Greater than or equal to is going to be a solid line, and then you're also going to shade over when you graph it. Alright, so let's go back to this now. We have already converted the inequality. So we have y is less than x minus 1. So because of that, let me scooch it on down. We know it's going to be a dashed line where we connect the dots and we're going to shade under. So let's figure out how to plot this. So let x equal -1. So I'm going to find -1 on the y-axis. So here goes -1. From that point, I'm going to go up 1 and over 1 because you see how you got x is 1. So up 1 over 1. When I connect my dots, it's going to be a dashed line, and I'm going to shade everything under. Now this is just a rough sketch. Let's go back to what it's actually going to look like on the computer, which would be this. So notice how you had your y-intercept at -1. We went up 1 and over 1. Remember, you will always go right. And you connected your dots with your dashed line and shaded under. Practice makes perfect.